Hello, welcome to Chapter 4, Lesson 3. Today we're going to be studying arrays. Okay, so an array has rows that go side to side of equal length and columns, which are up and down, of equal length. And so here is an example of an array that shows what 2 times 3 would look like as an array. So notice I have 2 rows and 3 columns, up and down columns 3, 2 rows, and that makes my array. And it's an easy way to see that we've got 6, right? So 2 times 3 is 6. So let's get started. All right, so here we have an array. This is the picture we just were looking at. Step 1, it says make an array on a piece of paper. Arrange the tiles in 4 rows. So if we had little blocks, maybe if you have little blocks at home, you could get little blocks out. But we need 4 rows. 1, 2, 3, 4. 4 blocks. 4 rows. Remember, rows go side to side. And 3 tiles in each row. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. What is the total number of tiles? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There are 12 tiles here. So if we turned this, now I have 3 groups of 4. So there are now 3 rows and 4 tiles in each row. All right, and now it says draw what the array looks like now. So I have 3 on this side. This is kind of a quicker way. Ready? So let's draw a rectangle. Why am I so shaky? Yikes. 1, 2. Now I have 3 that way, and 1, 2, 3. So now I have 4 across the top, 3 along the side. I don't know why this is rotating, and I can't figure out how to get it to stop rotating. So ignore that one. We're down here now. What is the total number of tiles? There are 12. Still 12, because all we did is we took our array and we rotated it, right? So there are the same number of tiles, 12, if you turn the array. Now, that is a demonstration of the commutative property of multiplication, because that says that the order in which the numbers are multiplied does not change the product. So let's see on this, okay? So if I have 5 rows with 2 tiles in each row. Okay, so I have 5 rows. 1, 2, 3, 4, 5 rows. 1, 2, 3, 4, 5. And then I'm going to double it because I have 2 of them. And I have 2 tiles in each row. Okay, so I would show 2 plus 2 plus 2 plus 2 plus 2. And that's going to equal 2, 4, 6, 8, 10. 10. So that would show, okay, I've got 5 rows with 2 in each row is equal to 10. Now if I turn the array, all right, so now I turned the array on its side. The numbers are a little sideways too, but now I have 2 rows of 5 tiles each. So now I'm going to do 5 plus 5. And we know 5 plus 5 is 10. So now I have 2 rows of 5, and that is 10. So let's look at the 2 multiplication sentences we found here. 5 groups of 2 are 10. 2 groups of 5 are also 10. Notice how we just flip-flopped our factors, right? And so that shows the commutative property of multiplication. We also learned last chapter about the commutative property of addition. So it works with addition and multiplication, which is fascinating because multiplication is just repeated addition. So multiplication and addition are closely linked, and they both share the commutative property, which means the factors or the addends can flip-flop. All right, question 1 in the guided or the talk about it says, what is the connection between repeated addition and an array? Well, each equal row, E-A-Q-U-A-L-R-O-W, each equal row can be added to find the total. In an array. All right, how can you use an array to model the commutative property? Well, you can rotate or turn the array on its side. And that shows, if it's standing up tall and we rotate it onto its side, that shows the commutative property. List 3 everyday objects that are arranged in an array. Well, what about a carton of eggs? A carton of eggs is an array. And it shows 2 groups of 6, or 6 groups of 2 if you rotate it, right? 6 groups of 2. You could also do a muffin pan. Now, muffin pans are usually 3 groups of 4 or 4 groups of 3. Let's see, is there anything else we can think of that are grouped in an array? I would say I'm thinking of like a box of crayons. Now, boxes of crayons usually have 24, so I'm going to say they have 4 groups of 6 or 6 groups of 4 when they're in the box. All right, so let's do an example here. Draw an array to find the product of 5 groups of 7. Okay. Now, this is my quick way. So I need to draw. If I need 5 boxes, that means I need 4 lines. 1, 2, 3, 4. Now, are yours probably going to be uneven? Sure. That's fine. We're learning. Okay, so I have 1, 2, 3, 4, 5 boxes now. And now I need 7. So that means I need to draw 6 lines. 1, 2, 3, 4. Uh-oh. I'm going to do this. 5. I'm going to add 1 on. 6. 1, 2, 3, 4, 5, 6, 7. Okay, so that means I'm going to count by 5s. So here I have 5, 10, 15, 20, 25, 30, 35. I have 35 boxes here. Okay. I think we've got it, so I'm going to skip this one and do a different example. Here it says write an addition sentence and a multiplication sentence to show equal rows. So here I have 4 rows and 2 in each row. So I have 4 times 2, or I could say I have 2 plus 2 plus 2 plus 2. So if I count by 2s, I have 2, 4, 6, 8. Equals 8 boxes for both. Right, here I have 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Oh, look at that. 5 groups of 5. Or 5 plus 5 plus 5 plus 5 plus 5. Count by 5s. 5, 10, 15, 20, 25. 25 total. Okay, that's all I have for you for today. Thanks for watching. Let's practice these arrays.